Okay, question 7. So here we have in the diagram OAB is a sector of a circle with center O, radius 2r for the sector. Angle AOB is pi over 6 radians, and the point C is the midpoint. We can also see that because that's r and that's r, which is the same length there. Okay, show that the exact length of BC, so this length, is that. Alright, well we've got a triangle with two sides given and an included angle, so we can use the cosine rule. Okay, the cosine rule says this. If we want BC squared, then we can say it's the other two sides squared, so r squared plus 2r squared minus 2 times those two sides times cos of the angle opposite to BC, which is pi over 6. Okay, so r squared is just r squared. 2r, if we square that, we get 4r squared. And then minus 2 times 2 is 4. And r times r is r squared. Times cos of pi over 6. So cos of pi over 6 is square root 3 over 2. Okay, so r squared plus 4r squared, that gives us 5r squared minus 4r squared. But let's also simplify that. So the 4 and the 2 can cancel to give us the 2 in front there. So 2r squared, I'm just going to write that as 2 root 3 r squared. Okay, so that's still BC squared. Now, if we want BC, we need to take the square root of that. But first, let's factor out an r squared. I just like factoring whenever I can. So 5 minus 2 root 3. Okay, now if we want BC, that is the square root of this thing. The square root of r squared, 5 minus 2 root 3. And if we take the square root of r squared, we get r. So the r can go outside, and then we're left with inside, it's just 5 minus 2 root 3. Well, there we have it. That is exactly what they have. Perfect. Next, we have to find the exact perimeter of the shaded region. Okay, so for this, I think I will just do it up here, because here we can see the picture, and then I can just copy it down. Okay, the perimeter of the shaded region. So that perimeter of the shaded region will be equal to BC plus AC plus AB, right? BC plus AC plus AB, that's the perimeter. Okay, so we already have, where's my pen now? Oh, there it is. We already have BC. We just calculated that. That is r times the square root of 5 minus 2 root 3 plus AC we have, that's given as r. So we just need to calculate AB. So to calculate AB, let's do that over here. That is just some fraction of a full circle's circumference, right? This part is just part of whatever some full circle would be. So the circumference of a circle in general is 2 pi r. So AB will just be this fraction, pi over 6, that fraction of a full circle times 2 pi r. And the radius of this circle here that we're looking at is 2r. So the radius of this circle, 2r. Okay, let's simplify that. So the pi's will cancel. A divided by 6 and a divided by 2 will give us 1 over 12 times 2 times 2 is 4 pi r. So 4 over 12 will become 1 over 3. So that's just a third pi r. Okay, so that is what AB is. That's a third pi r. And then, again, we can just factor out an r. I just like factorizing, but I suppose this will be good enough to get you the marks. But let's factorize. If we take out an r, what do we have left? Square root 5 minus 2 root 3 plus 1 plus a third pi. Or pi over 3 if you prefer that. Okay, so let me copy that to the next question, just so we have it in case I want to also save this PDF and send that through. We're going to do that, and I'll also copy how we found AB. This little part here. Also put that down here. So that's how we found AB. And let me just add, this is the circumference of a full circle. Okay, and the circumference of a fraction of a circle, so an arc length, let's just explicitly state that as well. That is the angle over a full circle times the circumference of a full circle. So in essence, we could also say this rule can simplify to those cancelling out and just giving us the angle times the radius. So you might have learned this formula, and that's where it comes from. Okay, find the exact area of the shaded region. So again, let's do that up top here, and then just copy it down. So the area of the shaded region, so this part here, that area, what I would do here, I would say it's the area of the sector, the whole sector OAB. And then we're going to subtract from that, sorry, we're going to subtract from that the area of the triangle OBC. And what's left then will be the shaded area. So area of the full sector minus the area of this triangle will leave us with this shaded area. Okay, area of the sector. So for a sector, same thing. We'll take our, well, let's say area of sector. Area of sector. Again, that is just going to be the angle over a full circle times by pi radius squared, the area of a full circle. So again, we can cancel these two pi's out. And we'll just have the angle of the sector over 2 times by r squared. Okay, so the angle of the full circle, which is pi over 6, divided by 2 times the radius squared. And the radius of our sector is 2r, so that's squared. So that's the area of our sector minus the area of the triangle. Okay, so let's just also write area of triangle. To calculate the area of the triangle, we can say that's half. Oops, let me just write it a bit better. Half times one side times another side times sine of the angle in between those two sides. So we have that here. We can say half of one side times the other side times sine of the angle in between them. Pi over 6. Okay, that's the area of the triangle. Okay, so let's calculate this. So here the 2's will cancel. The 6 will, so we just have pi over 6 times r, and that's not to the power 4. What am I doing there? That's squared. My apologies. So that's squared. Okay, so we can't cancel the 2's yet. We actually do this. Okay, pi over 6. Erase that to the power 4 again. Okay, so we can't yet cancel because there's still a square here. So pi over 6 over 2 becomes pi over 12. And then 2r squared becomes 4r squared. Minus, so half times 2 is just 1. R times r is r squared. So r squared times, and then sine of pi over 6 is just a half. So times a half. Okay, let's simplify that a bit more. So the 4 over 12 just becomes 1/3. So 1/3, and then we've got pi r squared. Pi r squared minus a half r squared. And again, let's factor out the radius squared, and we're left with the 3rd pi minus a half. Okay, and again, let me copy all of this down to the place where we actually needed to do the calculations, right over here. Okay, and again, that was that for question 7.